All right, so this is the video for the second part of section 5.3 in the textbook. The last lesson, which was quite short, focused just on different ways to express an interval, mainly what we call the set notation or interval notation, but just understanding ways of reading and writing how you express an interval. Today, we want to use that to describe domain and range. And these are terms that, again, I expect to be new to you, but will be used throughout the course.
Homeroom teachers to return your homeroom list after A block. Please make sure to return your homeroom list to the office after A block. Thank you.
It's very important. Return that homeroom list. Anyways, so let me get straight into it before I get more announcements. So these two terms, domain and range, like I said, I expect to be new. We're going to hear them again, not only for the rest of this course, but every math course you kind of take after this. So domain is a description of what goes into a function, into a relation, I'll say for now. It's a description of the independent variables, which is usually the x variable. It is either a list or an interval of all the numbers that can be put into a relation. Everything I'm highlighting in yellow is kind of connected. So a domain is a way of describing what goes into a relation. Remember, quite often we think about things having a number that goes in and a number that comes out, or what's on the x-axis and the y-axis, the independent variable and the dependent variable. I'd say of all those things connecting, independent variable and the domain are connected. And again, I'll talk about what I mean by a description of. Whereas range is the same idea, but for the output, for the dependent variables, which is usually the y variable. And that's what comes out of a relation. All right, so what does all this mean? As usual, the best way of understanding a definition is not to memorize it, it's to use it. And so here's a relationship. I want to say it's the domain and range. So I have this relationship. It's just a table. For this, x always equals 1. And here, y equals various things. Sometimes, when x is 1, y is 1. When x is 1, then y is 5. When x is 1, y is 9. Kind of strange how we keep having the same number for x and different numbers for y, but that's okay. A relationship can be anything. So what's the domain? A domain is a description of the independent variable. And again, this here is the independent variable, the x. And so it's pretty easy to describe. The domain is just the number 1. So that's it. The domain is the number 1. So how do we write that? Well, you have a bunch of ways. I can just say x equals 1. That's it. Or I can say, I can put these little, if I want to be a little more fancy, put some curly brackets with just the number 1. All the same. Okay, I'll go with that. I can make it needlessly more complex, but why? Okay, so range is a description of the outputs, these numbers here. In this case, it's the numbers 1, 5, 9, and 13. Now, it's not the numbers in between, it's just the numbers 1, 5, 9, and 13. So for this, by far the simplest way of describing that is just to list out those numbers. And just, you don't have to put them in order, but why not? 1, 5, 9, and 13. And generally, when we have a list of numbers, we tend to put these sort of curly brackets around it, which I did right here as well. There's my domain and range, right? Domain is a description of the inputs, the independent variable. In this case, it's just the number 1. Range is a description of the outputs, the dependent variables. In this case, the numbers 1, 5, 9, and 13. All right, so let's look at the next relationship. This time, I have a relationship described in words and an equation. It says the cost of gasoline is $1.32 per liter. The equation that describes this relationship is this. C, which is cost, equals 1.32 times V, which is the volume in liters of gasoline. Okay, so I have a relationship described in words and an equation. It's all the same thing. So what's the domain? The domain is a description of what can go into, right? That's my independent variable. And that's my dependent variable. That's what comes out. If we were to make a graph, volume would go on the x-axis, cost would go on the y-axis, right? But I'm not making a graph, so I'm going to erase that. So let me focus on domain first. This case, I don't have a table, I just have an equation. But V can be pretty much any number. It's how much gasoline we're buying. It could be 1 liter, 2 liters, 10.6 liters. The only thing, the main thing that volume cannot be is negative. You can't buy negative liters of gasoline. You can't buy 0 liters. You can't buy negative liters. And so the domain is anything greater than or equal to 0. And so, because as long as my number for volume is 0 and up, this equation makes sense. If volume is negative, in this case, that makes no sense at all. So the domain, I will say, is V is greater than or equal to 0. And that's really all I need. But there's always more ways of saying it. So that's in set notation. We also learned last day interval notation, which in this case would start with a square bracket, a 0, a comma, infinity, and a round bracket, because there's no limit theoretically to how much I can put in. Although, yeah, you may think you can't actually put in billions of liters of gasoline into a car, but so that said, mathematically to this equation, I can keep putting in bigger and bigger numbers, but I definitely can't put in negative amounts. So both of those mean the same thing. Remember again, this is what we call set notation. This is what we call interval notation. But they're describing the same thing. So what about the range? The range are the numbers that can come out of this, the dependent variables. And so for this, we need to think about, okay, first, what variable is that? Well, it's C. Well, let's think about, let's say we buy no gasoline. That's the smallest amount we can buy. Let's say we buy 0 amounts. Well, if we buy 0 gasoline, the cost will also be 0. If we start buying more and more gasoline, the cost goes up and up. If we start buying infinite amounts of gasoline, the cost gets infinitely high. So much like the domain, the range is anything that's not negative, essentially. All the possible numbers that can come out of this equation, the smallest possible number that can come out is 0, and anything bigger than that is okay, is possible. That's the range. All right, so again, I can describe that in set notation or in this interval notation, which would look the same as before, 0 to infinity with a round bracket. Of these two, I like these ones better because I see the variable. I see the variable C. I see the variable C. When you see things in interval notation, you don't actually get to visualize what that variable is. Okay? So notice it's probably already getting a lot trickier, even though, again, the domain is a description of what goes in, range is a description of what comes out. In this case, it's both 0 and up. All right, let's look at the next relationship. This time, our relationship is just a graph. What does this graph mean? I don't know, just some dots. But I can see the scale of the graph. Each grid line is 1. And so what's my domain? Well, my domain is the description of the inputs. In this case, I look at these points, but I just care about the x-coordinate. I don't really care about how high they are. I care about the x-coordinates. So what are these x-coordinates? Well, this is -4, -2, 0, 2, and 4. So, but not in between, right? These are discrete points. It's not continuous, right? That would be continuous, but that's not how it looks. And so my domain is just those numbers I wrote down, a list. And so a list can be in any order, but I think it makes sense to go smallest to largest, -4, -2, 0, 2, and 4. And then again, we usually put these curly brackets to show the start and end of a list. That's it. So what's the range? Well, the range is the same idea. I just care about the outputs. So I just look at these points. I just care about all these points here. All these points right here have a y-coordinate of 1. These 2 points here have a y-coordinate of 2, but not in between. So the numbers 1 and 2 are the only, there's the bell. 1 and 2 are the only points on my range. There we go. Thank you. So the range is just 1 and 2, and not in between. So again, in between 1 and 2 on the y-axis, there's nothing there. It's an empty graph. Okay, so discrete points lead to domain and range that are a list. Continuous points lead to points that are an interval, which you can't list them out. Let's get to the next one. This is continuous. And so for this, similar to before, I want to pay attention to, for the domain, just the x-coordinates. Well, if I look at all of this, I can't list it out because it's a solid curve. But I can see that my x-coordinates, everything I highlighted in yellow, goes from -2 on one side to +2 on the other. And in between, there's no holes, there's no gaps. It's a solid curve, either going up or down from -2 to 2 on the x. So that is my domain, from -2 to +2 and everything in between. So I can express this in a couple different ways. One way is to say -2 is less than or equal to x, which is less than or equal to +2. That is set notation. Or I can use interval notation, and they'd both be square brackets, because it's -2, because you can see it goes right up to those points. There we go. So that's my domain by looking at the graph. So for the range, same sort of idea. I want to pay attention to this whole curve again, but just the outputs, the y variables. Again, though, it's continuous, so I can't list out all the numbers. There's an infinite number of them. But I can see it goes all the way up to 4 and all the way down to -4 on the y, and everything in between. So the range is everything from -4 to 4. And so I can express that like this. -4 is less than or equal to y, which is less than or equal to +4. Or I can express this in interval notation. Square bracket, -4, +4, square bracket. Remember again, this set notation, this interval notation was really the focus of the last short lesson. And it takes usually some time to get a good grasp on that. Okay, so I think I have 3 more relations. Another graph. Okay, this time I got these open circles. These open circles, you may recall, mean we get right up to that point, but we don't actually reach it. So what does that mean? Well, let's look at the domain again. So if I look at this curve, and I'm focusing on the domain, I can see it goes all the way from 0, but not including 0, but then it's solid in between all the way to this point right here, which I don't know exactly where it is, but it sure looks like it's about 2.5. And you know, it's definitely pretty darn close to halfway. How do I know it's exactly halfway? I don't. I'm just going to make a guess here. So from 0 to 2.5, but not including 0 and not including 2.5, because at those points it's an open circle. So the domain is everything between 0 and 2.5, or 5 halves. 5 halves is the same as 2.5, and everything in between. So I can express it in 2 different ways. I can say 0, oops, not a comma yet. 0 is less than x, which is less than 2.5. Or I can say 0 is less than x, which is less than 5 over 2. Or I can put this in interval notation and say 0, comma, 5 over 2, but both round brackets. So all of these things mean the same thing. Again, I don't really care if you use a decimal or a fraction, as long as you understand how they're the same thing. 5 divided by 2 is the same as 2.5. A textbook would probably use the fraction, because we want to start getting more and more familiar with improper fractions in lowest terms. So that's the domain. Everything from 0 to 2.5, but not including 0, not including 2.5. So what about the range now? Well, for this, I just care about the outputs. And I care about, really, as I look at this curve, which I'll now highlight in blue, the highest point it ever gets to is 3, and it actually gets to 3 right here. That point is a filled-in circle, so it gets to 3. The lowest point it gets to is right here, which is -3. And I don't really care about anything else. I just care about the fact that it goes at some point all the way up to 3, all the way down to -3, and everything in between is filled in. So the domain is from 3 to -3, or I'll say smallest to largest, -3 to 3, but including those. Although I will say if there was a open circle right here, then it wouldn't include the -3, but there's not an open circle there. So we are to assume, by looking at it, that it's meant to go down to -3. So the range, -3 is less than or equal to y, which is less than or equal to +3. Or we can say square bracket -3, 3. Okay, so again, chances are you're finding some of this kind of tricky, which is why I'm doing a number of examples. But I only have 2 left. Okay, next, we're looking at 2 equations that are, 2 relations that are shown as an equation. And so this is what we call a radical relation. The word radical has to do with some roots, like square roots. And we'll deal with those a lot more later on in the course. That said, all that really matters is that I have an equation where the input I square root, and the output is just that. There's nothing else. I pick a number, square root it, that's my output. That's my x and y. So the domain is a list of all the numbers that can go into this equation. So you need to remember, with square roots, you can't square root a negative number. The square root of -2 is not a real number. Or, for example, a common mistake. People think the square root of -9 is -3, but it's not. A square root remembers what number times itself will equal -9. Well, -3 times itself is +9. And so when you square root a negative number, essentially we say it's not possible. I mean, technically, the better way to say it is it's not a real number. And so you just, but hopefully you remember, if you go to your calculator and you type in the square root of -2, it's going to give you an error. But the square root of 0 is okay. The square root of 0 equals 0, right? 0 times 0 equals 0. But the square root of -0.0001, a little bit less, suddenly will give you an error on a calculator. It's not real. There's no real number. There's no number that exists, a real number that you can multiply by itself and get a negative. And so the domain is everything greater than or equal to 0. Or I can show it like this, square bracket 0, infinity. Either of these. The range is the same thing, except with y, because if you put in a 0 right here, the square root of 0 is 0. That's the smallest number that will come out of this equation. That's it. There's no limit to how big y can get. If you start square rooting gigantic numbers, y will be still very, very big. And you can square root infinitely large numbers, so infinitely large numbers can come out. Again, range is actually a pretty tricky thing to think about. You're trying to think about what's coming, input and output for anything. Like, if you're finding this a bit challenging, that's to be expected. So the range is also greater than or equal to 0 or 0 to infinity with a square bracket first and then a round bracket. Because again, 0 is the smallest number that can come out, because you can't, this, like I said right here, 0 is the smallest number you can square root, and when you square root it, you get 0. After that, though, anything else can get. If you find the square root of, I don't know, whatever this number is, whole bunch of zeros, you're going to get some big number. Not as big as this, but still really, really big. And there's no limit to how big I can make this, so there's no limit to how big the square root can end up being. There's no cap on it. So here's the last one. X squared equals y, or y equals x squared. Again, we call this a quadratic equation, which is the focus of grade 11 math courses. So again, what's the domain? In this case, the domain can be anything. You can square, right? Raising to the power of 2 we call squaring. You can square any number. -3 to the power of 2 is +9. You can do that. You can square any number. So the domain is any number, literally any number that exists. And so you may recall from last day that if we want to say any number that exists, we can just say all real numbers. We can write that phrase. The domain is all real numbers, anything. Literally, there's no restrictions. You can square anything. Or we can write it like this. If you hate words, you can say x, and this means belongs to, and this fancy capital R represents all real numbers. You'll probably see that in the textbook as well. Those are the two I like the best. What I like the least is this, but it's not wrong. Round bracket, -infinity, +infinity, another round bracket. I find that kind of a silly way of saying all numbers, but that is correct. The range, though, is not all real numbers, because I don't care what number you pick, you will never get a negative number out. If you're picking a real number, I don't know, -10 for x, and then you square it, you're going to get out +100, not -100. And so you will never, never, never get a negative number out of this equation if you're putting a real number into it. And so the range is anything from 0 and up. If you put a 0 into x, 0 squared equals 0. And so but you can't get anything smaller than 0. So while the range is not all real numbers, the domain is. The range is everything greater than or equal to 0. Or, try that again, square bracket, 0 to infinity. So notice, even though we're still early in the course, I would be surprised if a number of you aren't a little bit confused right now. And that's because we're looking at something that's quite abstract. You're trying to, not just memorize these terms, but you're trying to think about really what's happening in a relation. In this case, you're trying to think about, okay, as I put numbers in, what numbers come out? And that's tough. And that's why we have a number of examples here, and that's why we have homework questions that we need to, to try to check our understanding. But in the end, if I go back to the start, remember, domain is a description of what goes into a relation. The independent variable, range, is a description of what comes out, the dependent. So with that said, your homework you have already, so I'm not going to write it down again. It's not a lot of questions, but expect some of them to be challenging. All right, and I'm going to stop it here.